So let's look back at this slide. Let's think about, so delta H. When delta H is negative, that means that it is exothermic, right? It's giving off heat. When delta S is positive, that means that we have a change in the entropy, an increase in entropy. So no matter what, if we are at low temperature or high temperature, it is always going to be spontaneous. So if your delta H is negative, your delta S is positive, then it's always going to be spontaneous, no matter what. Okay, here's an example. So it doesn't matter what temperature we're at. Let's skip down to the end. If delta, I guess it was the next one. So if delta H is positive, that means that it's endothermic. If delta S, if our S is negative, that means that it's not spontaneous, right? So it's endothermic, not spontaneous. Then that means that no matter what temperature we're at, our delta G is going to be positive. And so it's not going to be spontaneous. It does get a little bit different at different temperatures. So delta H, or our H of our system here, is negative. So that means it's exothermic, but it becomes more ordered. When we're at a low temperature, since we're getting more ordered, that must mean that even though it's exothermic, right, because it's exothermic, the energy change is great enough that at low temperatures it will be spontaneous, but at high temperatures it won't. Opposite is true. We took it, H is endothermic, and our delta S is, well, not delta S, sorry, our S of our system is going to be positive, so means we'll have a greater disorder. At low temperatures, it will not be spontaneous, but at high temperatures, it will be, because we don't care as much about that change in temperature at our higher temperatures. It's okay if you don't exactly get that, because we're going to do some math with it. It's a lot easier to see once we get our math. So as long as we know that delta G of our system equals delta H of our system minus T delta S. When our G is negative, that means it's spontaneous. When our G is positive, that means it's not spontaneous. So let's look at this reaction. So here's the decomposition of carbon tetrachloride. So here's carbon tetrachloride, right, going to carbon and chloride gas. They gave us a delta H and they gave us a delta S. So what it wants is calculate delta G at 25 degrees Celsius and determine whether the reaction is spontaneous. Well, let's see. Automatically looking at this, our delta H is positive, so that means it is endothermic. Okay, so endothermic, and then our delta S is going to be positive. So that means it becomes more disordered. So when we look back here, I said that our delta H was, positive. Okay, so delta H is positive and delta S is positive. Oh, so it could be spontaneous or not. So we would have to figure out which one it was. If we had delta H was negative, delta S was positive, we know that it would always be spontaneous, right? Or up here, we have delta H positive, delta S negative, we know it would always be non-spontaneous. But since we have both of them positive, we would have to figure out, is it spontaneous or not? So let's use our equation, delta G equals H minus T delta S. Let's calculate our delta G value. So we have the equation, here we go, delta G equals delta H minus T delta S. We know our temperature needs to be in Kelvin. So let's go ahead and change that 25 degrees Celsius to Kelvin, so 298. The other thing we need to look at, up here, delta H is kilojoules, right? Delta S is joules. So you need to make sure you change everything. What they did was they went ahead and changed it to joules. So change your kilojoules to joules for delta H. So delta H, we change that to joules. We get 95.7 times 10 to the third joules for our H minus, right, our temperature, 298, times our delta S value, which is 142.2 joules per Kelvin. As you can see, the Kelvins cancel. So we're just left with joules minus joules, right? That will give us joules overall. So if you do the math, your delta G value is 53.3 times 10 to the third joules. A positive delta G means that it is not spontaneous. So this reaction is not spontaneous. Then it asks us, if the reaction is not spontaneous at 25 degrees, okay, so it wasn't spontaneous, determine what temperature the reaction becomes spontaneous. So how would we do that? Well, let's see. Our temperature is what we're trying to determine, right? So we can plug in this equation. We're solving for our temperature now. Our delta H and our delta S are never going to change, okay? That is for this system. So those are constants. Our delta G, right? Delta G needs to be negative in order to be spontaneous. So what we can do is we can figure out when is delta G 0, then we know that above any temperature, right, it is going to be spontaneous. So we're going to set our delta G equal to 0. So if we set delta G equal to 0, right, you could do the math. So do some algebra, rearrange the equation. So first you would, right, get T by itself. So here's the expression for T. Your joules cancel, and you're left with Kelvin. So your temperature would be 673 Kelvin. That means above this temperature, it becomes spontaneous. So not necessarily at this temperature, but above it. So if it was 673.000001 Kelvin, right, it would be spontaneous. So above this temperature, it becomes